Hello, 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 hello. Increase volume now.
I think it's lagging. So,
Network.
is this light good?
Yes, it is.
Come as what I'm seeing on my screen. No,
It's dark on the screen.
it's not. Light is not good though.
Is dark on the screen.
Yes, it's dark here, but here it is.
We are good.
So he's just picking that one since network, Abby.
I think it's the setting. I'm like streaming from OBS straight.
All right. So what about the frame, the picture?
Picture is good. It's just the light.
What's it about the light?
Let me sit here.
All right. Good day, everyone. My name is Emmanuel Aderoju Adeyemo. I am so glad to be the privileged innovator at CMRC. All right. Last year we had free success project, and this year we have free success project 2026. In the last year, it was an amazing one. We had a lot of students who connected online this way, and they were able to excel in their jam exam. So at present, we have started with physics. We started on Facebook, and I hope some of you have joined us. If you have not, please go on Facebook to start with us on physics, and then we will be continuing now from here on YouTube. And we're enjoying that you share this link with everybody that they may take advantage. It is all free, and these tutors that are giving their time and their excellence to teaching you, they are astounding, and they would really really help you. They have been there, they have written and prospered excellently well, and then it is time for you as well. We don't believe in impossibility. In this year at CMRC, we are bearing fruit of excellence, and we want you to be a part of this. All right, so we welcome you. We want you to be glued, and we want you to share with everybody, and we want you to get blessed. Stay positive and know that this time you are making excellent results. Thank you. So I welcome my physics tutor coming back for you to have good time again.
I said before, and I said giving us 1 minute to solve this question. So now let's go to the solution now. So I said the half-life is 4 days, 4 days, and then I asked that the fraction that has decayed in 16 days is, I said the formula is NT equals to NO 1 over 2 n. So now the first thing you're gonna do here is that note they said the fraction. So that means that there's gonna be like the fraction of the NT and NO. So that means that we're gonna divide this by NO, divide by NO. So now we're gonna have something like NT equals to 1 over 2 raised to power n. So now say NT over NO equals to 1 over 2 raised to power n. Now what's formula for n here? N equals to T over half-life. So n equals to, what's total time? 16 days. And then what's the T half-life? Is 4 days. And 16 divided by 4 is what? Is 4. So now here you can input the n here. So now the fraction, which is NT over NO, will be equals to what? 1 over 2 raised to power 4. 1 over 2 raised to power 4 is what? 1 over 16. The fraction that has decayed is what? It will be what? 1 minus 1 over 16. And then that's what? 15 over 16. So that's the answer. The answer is what? 15 over 16. So now this kind of question can be very, very tricky somehow, because in the options you will see 1 over 16, you will see 15 over 16. Now you'll be like, okay, which one should I choose? And then most times the one that is actually the most correct sometimes will be like, okay, 1 over 16, because you actually solve it from the real equation. But to be candid, when you are thinking about it, or when you are trying to solve questions that deals with fraction, you must know that the total, let me say the total amount of that particular, of that particular variable will be 1. So now 1 minus 1 over 16 now, which is the remaining amount, NT over NO, will be what? Will be 15 over 16. So that means that the amount that has decayed is 15 over 16, but the amount that is left is 1 over 16. So you should know that there is a difference between the amount that has decayed and the amount that that is remaining. So the remaining amount is what? Which is 1 over 16, but the amount that has decayed is what? 15 over 16. Always keep that in mind. Again, let me repeat. In questions like in JAM questions, they will put the two formulas. You will see 1 over 16, you will see 15 over 16, but you will feel like, okay, since you have solved it using the right way, 1 over 16 will be correct. But this 1 over 16 is the amount that is remaining. So, but the question says that the fraction that has decayed in 16 days is 15 over 16. Not that. So now let's go to another question. Another question now. But this one should be simpler than the first one. Radioactive substance. A radioactive substance decays. A radioactive substance decays to 1 over 16th of its initial amount in 40 days. So the question now says the half-life of the substance is so you have 1 minute for this as well. Try to solve the question. It says a radioactive substance decays to 1 over 16th of its initial amount. It's a very simple question. 1 over 16 of its initial amount in 40 days. The question now says that the half-life is, majorly the formula you should use is this. So, but, you can try to think. 1 minute. a radioactive substance decays to 1/16 of its initial amount in 40 days. It's a typical JAMB question. You know, say that the half-life of the substance is so now let's move to the solution now. Yeah, you know, they says it decays to 1/16 of its initial amount. So that means that we do not know the initial amount. So let's say that let's assume that the initial amount is, let's assume the initial amount is what? Is n naught. So now that means that the nt, which is the remaining amount that it decays to, it be what? It be 1/16 of n naught. That's what? N naught over what? Over 16. So that means that there is a relationship between what? Between nt and n naught. So nt is what? Equals to n naught over 16. So that's the first thing you should know. So now we can move to this formula again now, since we have gotten a relationship. So now we can say, since nt equals to no 1/2n and nt equals to n over 16, so you can say no over 16 equals to what? Equals to no 1/2 raised to power n. So n cancel n, I'm saying n will cancel no. So that means that 1/16 equals to 1/2 raised to power n. And then you know that you can have something like finding the square root of 16, or let me say the triple root, and then triple root of 16 is what? No, or let me say the what do you call it now? Let's put it like this. Okay, 1/4 times 1/4 equals to 1/2 raised to power n, and this one too can also be say 1/2 square times 1/2 square equals to what? 1/2. It's not clear like this. And but 1/2 raised to power 4 equals to 1/2 raised to power n. So now eventually n will be what? Will be equals to 4. So that now n equals to 4. Now we haven't gotten the half-life yet. The half-life is what? Is still here. This half-life. We have just gotten what? The number of half-lives. So you see now we are still moving a step further. Now after that, so we can say, since n equals to the time taken over half-life will be what? Will be time taken over n. And then since time taken is what? Is 40 days. So that's 40 days over 4. And then T half-life is what? Is 10. So T half-life is what? 10 days. That's the right answers to that question. Yeah. So now you see it's a very tricky question somehow, because they are going to put 4 again. They're going to put crazy options that looks appealing, or let me say looks correct. Yes, jam option will look very correct, but still we haven't gotten there yet. So so you have to be very patient when you're solving questions on radioactivity, because you feel like 4, yes, I can choose 4, but the answer is actually 10, because you have to move a little another step further before you can get to the answer. So now let's move to another question, another interesting question now I have here. Yeah, there are some interesting questions they have. Okay, so the question says I will not erase all these formulas, because they are actually the one we are using. Okay, so now the question says a sample of strontium. Yeah, strontium also is a what? Is a radioactive substance, but not all isotopes of strontium actually. You know, I've mentioned that earlier. They are what they call radioisotopes. As we know what isotope means, So we also have radioisotopes as well. So now that means that the radioisotope of strontium has a mass of 12 grams. So the mass is what? The mass is 12 grams. The question now says determine the on-decay mass. So we are finding the on-decay mass. So the question says as a sample of strontium has a mass of 12 grams. So the mass of strontium is 12 grams. Let me write it very well. Very well. So the mass of strontium is 12 grams. So now the question now says determine the on-decay mass, the undecayed mass after 84 days. After 84 days. So the first thing is that whenever you are trying to solve this kind of question, try to identify the parameters from here. So you know when you hear 84 days, you know that's talking about the total time taken for degradation. That's talking about the T. But the question is not complete. Given that what? Given that the half-life equals to 28 days. So you can use 1 minute to solve this as well. These are simple questions. So the major thing you needed are what? The mass, 12 grams. It says find the on-decay mass after 84 days. Half-life 20 days. So take 1 minute to solve this question as well. Using all these parameters, these are what you actually need. And just simple thinking and critical thinking. Yeah. That's the second more. These are questions you have to just solve faster and move on to the next. So now, okay, let's quickly solve this question again. So now again, on-decay mass means that the remaining amount, and that's what that's. On-decay mass means that the remaining amount, and that's what that's NT. Yeah, you know when they say on-decay mass, the mass that will be that's NT. Yeah, you know when they say on-decay mass, the mass that will be remaining, that's NT. So you can say, okay, yeah, since that's true, NT equals to what? NO. What's NO? The initial amount, which is 12 grams. 12 grams, 1 over 2, initial amount, which is 12 grams. 12 grams, 1 over 2, raised to power N3. That's NT equals to what? 12, 1 over what? 8. Because 1 over 2 times 1 over 2 is 1 over 2 times 1 over 4. 1 over 2 times 1 over 4, 1 over 8. That's now 12 times 1 over 8 is what? 12 over 8. So what's 12 over 8? 12 over 8 would be what? Use my calculator here. 12 divided by 8? 1.5. 1 point. So the 1.5 is the what? Is the remaining amount after this has degraded. So they can ask you again, what is decayed mass? That would be what? 1.5 minus what? 1.5 removed from 12 grams, which is what? Which is 10.5. Yeah. So now let's take 2 more questions before we round up. Because you know the more you solve questions on with the solutions, so by the time you are very fast, you can solve the question within 30 seconds. A typical half-life question can be solved within 30 seconds. Yeah. So now let's take 2 more. 2 more. Let's take a very simple one now. Yeah. So now, this is a very interesting question that jams often set. 73, 33, as 13 plus what? Plus x. Give us what? Give us 73 geratium. Is it geratium now? I think it's I want to remember the thing now. So now what's x? What's x here? What's x? So you can say, okay, what's x? We can give you some, okay, we can give you protium, we can give you deuterium, we can give you alpha particle, we can give you beta particle. So now you have to be able to identify the x here. So now for us to be able to get it, you know, I told you that earlier in the Facebook streaming, on physics training that there are majorly three radiations, three particles, though two particles actually. The last one, which is gamma radiation, is not a particle, is like a wave, is an electromagnetic wave. So now, so in any, though there are other particles, there are positron, that's positive electron, there are betatron, there are cyclo-megatron, but those ones, they are most likely they are mostly used in therapeutics. Yeah, as I've said, in industry I works with radiation because they are mostly because their demerit actually more than their merit. So that's why the major radiation that is being used mostly is gamma. Yeah, it's very, very useful. So from here you can say, okay, X, you have to balance the equation, right? How do you balance the equation? Just check for two things. The first thing is the mass number. You have to check for mass number. You have to check for mass number is what? Is the number at the top left corner. Yeah, left corner of every kind of hypothetical element and real element as well. So now, and then we also have the atomic number. Atomic number is always at the bottom left corner of any hypothetical or real element. Sharp. Yeah. So now from here, whenever you are trying to balance any equations with radioactivity equation, any kind of equation, you have to make sure that these two parameters are balanced on the two sides. So now here, that means that there will be something here and there must be something here. So now that means that 73 plus x must be equals to what? 73 for mass number balance. Yeah. And then the next one, 33 plus y must be equals to what? 32. That's for what? Atomic number. Or they call it what? The proton number. Anyways, yeah, so x here will be what? 0. And y will be what? Y will be 32 minus 33, and that's minus 1. So you can say, okay, since there's something that has 0 and minus 1, what could that be? So you feel like, oh, I remember that it's a beta particle, because beta particle is massless, number one, and also has a negative charge. So that means you can go for, that means that it is an electron. So electron is the correct answer here. Very simple question. So you can see these kind of questions too, and they can be too complex sometimes, that they can be very, very long. But as long as you have the mental, as long as you have the understanding of how we can solve it, you can be able to solve any kind of question. I said that there is also what they call positron. Is a bonus now. Know that there are also positron. Positron are positive electron. So positron is like this now. It's like this, E, O, and 1. So there are also positron. So you should know that as well. And also, let me give us another one here on this kind of question here. Another one on this kind of question. On this kind of question, and I want you to solve it as well in 1 minute. We have 210, 84, polonium. Give us what? Give us x plus 206, 82, and lead. So what's x? What's x? This one is a very simple one. You can even solve this one in 2 seconds. Yeah, so okay. So now x will be what? Oh, sorry. As I said, mass number I'm talking about. Those are the two you need. So 210 xy. 210 plus x equals to 206. So x will be what? X will be, yeah. What am I? Okay, sorry. Plus x. So now x will be what? 210 minus 206, and that's 4. So that means that x will be 4. And then for y, we have 84. 84 equals to 82 plus y. So y will be what? 84 minus 82, and that's 2. So y is 2. So you have x, 4, and 2, which is helium particle. Is an alpha radiation. Helium particle and alpha radiation. As about that. So then let's take one more question before we call it a day. Yeah. So the last question now is a very is the question I want us to solve without using any formula, but just by thinking and then solving question, because the question can come that way as well, like without, you know, they want you to use your critical thinking skill rather than just knowing formulas. And then yeah, so the question comes like this way: a radioactive substance. So a radioactive substance. This marker is not really okay. A radioactive substance. Initial amount is NO. Okay, you now say what is the amount degraded after 3 half-lives? Though you can see this formula, but you know, I want us to put it out. I want us to solve it without using half-life now. Yeah, solution. Yeah. So now, how can we solve this without using half-life? Now, I told you that what does half-life means? Half-life means that the time taken for a particular sample to get reduced by half. So now that means that for the first half-life, the amount will be what? The amount will be what? Will become what? NT will be what? NT will be what? NO divided by 2. Abi now. So now the second half-life, NT will be what? NO over 2 times 1 over 2 divided by 2 again. So for the third half-life, we have NT will be what? NO over 2 times 1 over 2 times 1 over 2. And then that's third half-life. Yeah. So and then that will be what? That will be equals to what? Equals to NO over what? Over 8. Yeah. This is NO over 4. So now when you now say what is the amount that has degraded after 3 half-life? So we can say that will be what? That will be this one for the first half-life, for the second half-life, for the third half-life. So that will be what? NO over 2 plus NO over 4 plus NO over 8. And that's what the common SCM is 8. So that's 4NO plus what? Plus 2NO plus what? Plus NO. And that's what? And that's 7NO over 2. Too much. So that work actually was being further discovered by Marie Curie, a young scientist, which then discovered that this rock called pitch blende can actually emit, or let me say, can actually glow faintly in darkness. And then from there, radioactivity comes to life. And then since then, we have been using it, and they have used it in medicine, in industry, in sterilization. They use radioactivity very well. Units being Becquerel, Curie, yourself Gray, and yourself Rutherford as well. So those are the units of radioactivity. So thank you very much for your time. My name is Hallelujah Folayemi. Yeah, I'll see you.